This is Climate Watch. I'm Zhao Ying. Welcome to the show. China will accelerate the development of zero-carbon industrial parks and factories. This year's government work report has highlighted the strategy as part of the country's broader push to promote green and low-carbon development. The report also pledges to accelerate the construction of smart grids, develop new types of energy storage, and expand the use of green electricity. In China, about 80% of industrial companies are located in industrial parks, which together account for roughly 31% of the country's total carbon emissions. China plans to establish around 100 national-level zero-carbon industrial parks by 2030 during the 15th five-year plan period. Across the country, 52 pilot projects are already underway. For more on this, we're joined by Professor Qu Qiang, a fellow of the Belt and Road Research Center at Minzu University of China. Professor Qu, thank you so much for joining us.
Yes, thank you.
We know that in China, the vast majority of industrial activity happens inside specially designated industrial parks. So first of all, can you explain what an industrial park is in the Chinese context and what role these parks play in China's industrial and economic development?
Well, industrial park actually, by its definition of features, it's it's a park, it's a campus that have certain area and have been planned with a certain purpose in a certain position, and majorly focusing on the certain industries or supply chains. This kind of industrial park is always initiated by the government or the very big enterprises dedicated to special industrial activities. Just imagine that. Sometimes, our location of businesses doesn't always go in line with, the infrastructure's policies. For example, you are a AI training company, or you are computing or like data centers. You need to use lots of powers, but in Beijing and Shanghai, the power are really expensive and very hard to find enough spaces to accommodate to that kind of data center or the warehousing for the computing powers. So where do you go? I think the easy answer in China is to go to the western part of China, like the Xizang, right? They have very vast of the land and a very, very affordable land price. And meanwhile, those are the regions that generate most of the powers in China, and the green energy in those areas can actually be down to like 10 cents every kilowatt hour. So how can you use that kind of the very good advantages so you can build a industrial park in there? Because if every one single enterprise, like the AI company, a data company, go there, you need to find the land, you need to find the policies, you have to go through all the red tapes, registration, taxation. Everything will eat up your profit margin and also cost you lots of the time and the human resources. But now you build a local government to build an industrial park, let's say several dozens of the acres of the land, and then you can locate your company in there. The government will take care of all the infrastructures like the power, like the Wi-Fi, and also they can set up the government branch in there. Every department, taxation, registration, laws, and everything within one building. You don't need to go out the industrial park. You can get everything settled. You can locate your company in there, register your company in there with just in one day or two. And also you can get access to the latest or the most advanced infrastructures in there because government has already taken care of all that. And surrounding you, your neighbors would probably be upstream or downstream or your trading partners in there. So everything gets so efficient. So that is industrial park in China. You can right now find all kinds of industrial park in China of all sorts in every location. Sometimes it's designed for, the shipment of overseas for the trade, international trade. Sometimes it's in Western China facing the heavy industries. Sometimes it's in the middle of China facing the logistic industries, because in middle China, it's very easy to ship everything to every corner of the China because it's in center geopolitically, and also its transportation hub is very complicated. It's very efficient. So that's one secret recipe of Chinese economy's fast growth in the past, 2 decades.
Okay, so now China is trying to build zero-carbon industrial parks. Can you explain this term to us? How is it defined in China?
Well, zero carbon, basically, we don't have a unified definition of it. But basically, you get from the idea that is the whole industrial park, you need to be really green and really efficient. especially in the regard of the carbon emission and also the energy consumption. So usually it's direct emission, and also the power is consuming needs to come from the green sources. And these actually allows us not only to use the absolute zero emission or net zero emission technology, but also you can use carbon trade or CCUS and technologies to offset your potential, emissions. So basically, I think currently we are following a very realistic path. It's very hard for every, this kind of industrial park to go absolute zero in the very beginning. But you can go from very low carbon to nearly zero carbon. And then I think the last stage would be the absolute zero carbon. So I think we will allow as this kind of phasing in, of the gradual progress can be made. So I think I currently in China, the NDRC, which is the ministry in control of all this kind of industrial development, and also the NEA, the National Energy Administration, they all have all kinds of the policies and documents trying to guide those kind of industrial park evolving into the zero industrial park.
Okay, so when it comes to decarbonization, what additional advantages do these industrial parks offer compared to individual factory level decarbonization? Like, can decarbonizing at a park level create a synergy effect where the whole is greater than the sum of its parts?
Yes, I think going green and low carbon is actually the very important requirement for the government towards all industries. That's for sure. But for each and every industries or each and every businesses, especially the small enterprises, if they want to go zero carbon, it's going to be actually very expensive because you have to adopt it to lots of latest technology like the carbon capturing, like all kinds of the green power, get access to the green power grid, and that kind of installation fees and also the improvement fees actually eat up your profit margin and, cost you a lot of things. But if the government help you to do all this kind of a pre-installment together, and that actually can help us to avoid redundant, constructions. For example, the government can actually build up the infrastructures of the smart microgrid or smart, green energy storage and pipelines. So you don't need to do on yourself. You just rent the government infrastructures with very low prices, and that's going to be it. And also, for single companies, they probably will need, a mix of different source of energies. For example, in some companies, in their heavy industry part, they will probably still use traditional energy, so they need to use the carbon trade to offset this kind of emission. But on some other part of their companies, for example, they're building the light industry or service sectors, they are probably using directly the green energies. So they need actually the whole mix and different layers of energy structures to offset their emissions and to achieve the green target. But this is going to also, again, going to be very expensive. But if you can put everybody together and for each single type of energy, consumptions, the sheer value will be very large. So that I can lower the per unit prices on each energy consumption. It's better than you do it on your own with so much of the diversification. And more than that, I think when lots of the companies, cluster together to shoulder all these expenses on the infrastructure, on the government expenses, taxations, or the carbon trade. And I think it's going to be much, much cheaper. Everybody knows with more people get inside, the per unit or per person cost will get lower. And meanwhile, it's very good information sharing systems because everybody, when put together, the government will be very efficiently to deliver the latest policy, most favorable taxation conditions to everybody instead of, telling each of you each time. So I think this scaled economy and the diversification and the sharing of the cost actually become very important advantage for the industrial parks.
Yes. So looking at the first batch of pilot projects, there are 52 of them. What are the key measures being used to transform these industrial parks into zero carbon or near zero carbon systems?
Oh, I think currently we have the first batch of 52 pilot industrial park of the zero carbon. What they've been doing is number one, they try to provide directly a green power. Right now, I think they have distributed power generation, and also they get access to the smart green grid directly. which used to be very difficult or expensive for single enterprises, especially small enterprises, to do on their own. And now I think the park actually provided everything. You just need to plug in, then you can get up to, the absolute green energies directly. The only thing you need to do is to pay the power fees like you do previously in your home. And secondly is that many different companies have different, like we mentioned, different energy demand. For example, your company need to operate in the morning and my company need to operate during the night. And sometimes you do know that there are curtailment of the green energies, right? Because wind or the photovoltaic powers actually been generated mostly in the daytime when wind are stronger, when the sunshine is stronger. So you will probably get the power surge during the day and you get the power, bottom, power off during the night. So you need the power storage and supply for different companies. So sometimes the companies in the daytime, when they consume more of the powers, they can build these power storage, facilities together with the government, so they can save the energy and then provide the energy toward the company who needs to work during the night. So this actually can balance the curve, smooth the curve and balance the whole power consumptions and generations to make the whole power grid and the use and the demand and the generations are, to be more balanced. And meanwhile, because we have more players, more scenarios, so we can have more digitalized and the smarter power grid in here and to form a circular economy together. Some companies probably will generate more of the industrial waste, and some other companies can pick up the waste and burning all these garbages to create, the powers. So the more players you get into this scenario on a grid, and I think there are more efficient it can be and more possibilities you can generate.
We see that most of the first 52 pilot projects use a park within a park model. Why is it necessary
Mhm.
to start with these like smaller self-contained boundaries?
Yes, because we just mentioned about it's going to be zero carbon, right? So actually, the zero carbon actually required us to phase in into our, ultimate goals in a gradual way. That means we need to control the risks. Sometimes I cannot promise the government the whole park or the whole campus will be absolute zero carbon. So I need to try. I need to fence off or ring fence a small part of my park to go absolute zero carbon, to try this out, testify my technologies, and pull in all kinds of the technologies and resources and policies I have to make sure, okay, I have a campus. Probably have 10 zones. At least I have to make one zone out of it to work with zero carbon. And I will try on that with all kinds of recipe of the policies and resources technology to see how this can actually been happening. And after I test it in a successful way, I can expand it to some other zones like zone 2, zone 3, zone 4, until the whole 10 zones within my campus actually can work with all this combo of policies and technologies. And also, it's easier to manage all things within the small areas with small number of the companies rather than just go, all around with all these companies in the big, very big campuses. Because you have to know, in some industrial zones, industrial parks in the western area like Xinjiang and Xizang or Inner Mongolia, those parks can be really, really big. It's probably like a yellow rock, or natural reserve, like that kind of a big. So you don't want to endanger all these kind of resources and waste your time and energy. You need to do one by one. I think that's the reason of it.
Yeah, but if the goal is a national decarbonization, are we worried that these green islands might stay islands? And how do we ensure the bridge is built between the pilot sub-parks within the parks and those old heavy emitting factories next door?
Oh, I won't want to call it the green islands. Actually, we call it green, flags. When you can actually make it work in one zone, you put a green flag on it. It does not mean, okay, only this zone, the zone one, actually can go green, the others can't. At least we'll make one zone work. And now we can form the standard out of this practice. We can have all these physical access out of this, a good example, like try to see how they're working on their microgrid or smart grid, how they consume all this green powers, what kind of power mix or power model they've been using. And also we can see what their industrial mix they have in this one zone, like how many heavy industry, how many light industry, how many services industry, how many big enterprises, how many small enterprises, how many of the chemical industries, how many AI companies, what kind of a mix can actually make this work. So we call it a successful module, and then we duplicate the also module to some other areas, expanding the successful stories, replicate all these successful modules to the other places. So until we can have the green flags on every zone, and we call us a win. So it's not a green island. It's just a green victory after another victory.
Okay, well, actually, some pilot parks do include traditionally hard to abate sectors like steel in Tangshan and chemicals in Jilin. So, is this a sign that China is trying to move from the easy wins to those hardest problems?
Oh yes, we need to phase in and ease into those kind of tough jobs. Industry of iron and steel, aluminum, chemical industries, those places actually can be very, very difficult because they have to consume lots of energy. The energy consumption density is actually very large. So we need to also do pilot program out of there. We cannot just go full around, say, okay, every iron and steel company stop using the traditional energy and try to go green immediately. No, that's not how it's working. So I think the government also want to, cross the river by filling the stones. For example, we try to use the green hydrogen to replace the traditional energies. We try to use the CCUS technology. We try to use the carbon trade, with the carbon emission, this kind of a financial tools to offset their emissions. And also, by all these new systematic thinkings and innovative ways, we try to lower our cost. But meanwhile, we have to go green. And don't get it wrong. A lot of people say, why are you going through all these fusses? Why you just learn from Trump? Just go back to the oil. Just go back to the coal. And, you have lots of coals. And even though it's getting dirtier, but still it's cheaper. Why just to go through all the troubles? The actual thing is, in the future, a lot of countries actually have their zero carbon standard. So if your iron and steel are made out of the dirty energy, traditional energy, they wouldn't accept your, products or put a extra toll on your products. Say, okay, your iron and steel have been used to been produced with the carbon or oil, and then probably I'm going to charge you another 30% or 50% of the over extra tariffs. So it's not worth it. So we need this green label if we want to, trade with all the partners globally, with European Union, with North America, Canada, Mexico, Latin America, with Japan, with South Korea. They all have this standard. So it's going to be the trend. You cannot just stand in the past and say, okay, I'm the number one country. I can make the rules. I don't want to go green. This is not how it's going to work with China.
Yeah, so do you mean that at the current stage, these zero carbon industrial parks would require significantly higher upfront investment compared to those conventional industrial parks? Because many would be asking, in the long run, could these parks are they expected to lower the costs for companies? Like, how predictable are the economic returns?
Oh, yes, that's a great question. Yes, you absolutely need more of the free investment in here. But the good news is that we have already been doing it like 10 or 15 years ago. I still remember this kind of infrastructures and technologies have been doing like 15 years ago when I first visited several of the solar panel and smart power grid companies in 2010 in Zhejiang and in Jiangsu. Actually, in those times, I do have to say, cost is really high. It's much, much higher than traditional energy. You need to tear down a lot of old things and build the new things. For example, you need to have this distributed solar and wind power. You need to have the power storage. Power storage can be really expensive. And also you need to remodificate the whole of your power grid. You have to have the smart meter. You have to have the microgrid. You have to have the digitalized platform for the monitoring, not only for power consumption, but also for the carbon emission. You need to have the carbon capture. You need to upgrade some other annex infrastructures like the buildings, like the pipelines, and everything needs to be do from very beginning to do the new things. And also you have to have, the whole new set of technologies standard, monitoring standard and everything. But we have already been doing that for more than 15 years. So currently, if I want to do the zero carbon industrial park, it's much, much cheaper than not only than us ourselves 15 years ago, but also it's much cheaper than many of the other countries currently, our trade partners, our friends, the other countries. So I think if we want to build this kind of a zero carbon industrial park, I think the cost is actually being 50% cheaper than before because we have already done all the frontal jobs. So I don't think it's going to be a problem anymore. And also the new technology are popping out, like the green hydrogen, like the CCUS. And also we have innovated, financial tools like the green bond, like the carbon neutral funds. And also we have the EMC management and also the government special bond to help us to lower the cost with the financial tools in the longer run. So I don't think the cost is a problem right now. The problem is that how many companies and government, local government actually can adopt this latest way of thinking and try to move into this, the next generation of industrial park.
Okay. Thank you, Professor Qu. That is Qu Qiang, a fellow of the Belt and Road Research Center at Minzu University of China. To further explore how these policies are translating into real-world business practices, I also spoke with Li Hanxi, the lead sustainability officer at HyperStrong, an energy storage system provider in China. We discussed how companies like HyperStrong are contributing to the development of zero-carbon industrial parks and what this transition means from a corporate perspective. Hi, Hanxi. Thank you so much for joining us.
Thank you, Zhao Ying. I'm really happy, really glad today I could be here.
Well, we know that HyperStrong is involved in building zero-carbon industrial parks in several locations. Help us understand the role of energy storage in helping industrial parks achieve their zero-carbon goals.
The thing is that on the middle year of 2025, 5 national authorities of China jointly issued the guiding opinions on the construction of zero-carbon factories. The document clearly calls for a systematic approach to developing zero-carbon factories and zero-carbon industrial parks. I believe that the core value of energy storage lies in the efficient and stable utilization of green energy. For a factory to achieve carbon reduction at a source, the key is still to transition away from fossil fuel, right? And to continuously raise the share of renewable energy consumption and the level of electrification across the entire production process. As companies do that, they need more and more storage as the share of renewables continues to rise. Because many forms of renewable have this intermittency problems. That is what happens when there is no sun, like at night or when there is no wind. So we need energy storage systems to transform clean energy from an unstable supplementary source into a reliable primary energy source.
We know that earlier this year, China released a major policy roadmap requiring industrial parks to consume at least 60% of their green power on-site by 2030, while limiting exports to the grid to 20%. So under these rules, do energy storage systems become a necessity rather than luxury for industrial parks?
I believe this policy in China is aiming to promote higher use of renewable, not to put it on the grid, but to consume it at the source. But because of the intermittency and other reliability problems, the reality is that most industrial parks prefer to connect to the public power grid rather than to adopt directly green power connection. In contrast, grid connection is very stable with low cost. Therefore, in order to achieve 60% on-site consumption, I believe energy storage is absolutely essential. Clean energy sources like distributed PV in factories and parks fluctuate significantly with weather, day and night, and seasons. Energy storage systems can store power during peak generation periods and discharge during peak demand periods, effectively mitigating such intermittency and instability.
Well, we often hear about zero carbon factories, but a zero carbon industrial park involves many different companies. So, how do you coordinate energy use and sharing among different tenants in a park to ensure that the whole area stays net zero?
The core of coordinating a zero carbon park with multiple enterprises lies in shifting from fragmented operation of individual entities to systematic collaborations across the entire industrial park. We can achieve the overall net zero by building an energy ecosystem that integrates technology, the market, and also contractual obligation. Specifically, at the physical level, it is necessary to build a smart microgrid and a centralized energy management system with real-time monitoring. So that one can predict and optimize the energy demand of each enterprise that is based in the park. We also need to build shared energy storage systems which can be used to support and mitigate fluctuations and grid load. Then the business level. It is important to design market-oriented mechanisms to enable green power purchases or share leasing of energy storage, so that enterprises can not only reduce carbon emissions, but also they can save costs, right? Third, at the government level, we need to clarify the rights, the responsibilities of all the parties, and establish transparent profit sharing rules, thereby reducing long-term coordination costs through consensus. It also should be noted, though, that this national level zero carbon market initiative does not aim for its absolute net zero carbon emission in the full life long-term circle. Rather, it is a high standard development model centered on controlling carbon emission intensity, increasing share of renewables, and supported by digital monitoring and smart management. It is trying to emphasize the low carbonization of unit energy consumption, a cleaner energy mix, and improved accounting and transparency of carbon emissions.
Yeah, actually, I learned that many Chinese companies are also working toward lighthouse factory status, and that is a World Economic Forum designation for the world's most advanced factories. In simple terms, what makes a factory a lighthouse, and how do these smart manufacturing technologies help support zero carbon goals?
Simply put, a lighthouse factory is like a top student in the global manufacturing industry. These factories need to truly use technology to solve practical problems, such as significantly improving production efficiency, reducing costs, or cutting energy consumption sustainability, so that they can serve as role models and the guiding lights for other factories. In simple terms, it can come down to three pathways. First, you don't waste electricity. Use sensors and AI to monitor every machine in real time, optimizing immediately whenever power usage spikes. It is like installing a smart energy saver for the factory. And the second one, you don't want to waste materials. Reduce defective products through precise control. The fewer raw materials you use, the less carbon is emitted from producing those materials in the first place. And the last one is the early warnings. The system will alert you in advance if a piece of equipment is about to fail or if carbon emissions are about to exceed limits, preventing you from having to fix a major disaster after it happens. This saves both energy and maintenance cost. So we come to the core logic is that the intelligent technology makes production more lean, and when production is more lean, the carbon emissions naturally become lower, right? So that for a company, this approach saves money and reduce carbon at the same time. It is a win-win, we say that. And I also want to mark another point is that in the field of green low carbon development or even sustainable development, the evaluation of lighthouse factories can go far beyond just advanced technology and efficient operations. We also need to place greater emphasis on how enterprises integrate energy conservation, consumption reduction, pollution control, and carbon reduction into their production and operation through digital process. On one hand, it is necessary to continuously improve efficiency of energy utilization and recycling rate, reduce carbon emission and environmental damages. And on the other hand, it is also necessary to improve labor productivity, delivery agility, market response, and also the customization capabilities.
Under the past 2080 standard, companies are expected to look at the full life cycle carbon footprint, including their suppliers. But how realistic is it today to source low carbon raw materials at scale? And does your company actively support your suppliers in reducing their own emissions?
I believe there are some examples where large-scale procurement of low-carbon raw materials has been achievable. For example, some automakers that we all know, such as Mercedes-Benz, Volvo, and also BMW, are all signed long-term procurement agreements with green steel producers. And over 90% of steel producers in India have stated that they are ready to supply certified green steel. That is a really high rate. Of course, we also acknowledge that the cost of green raw material is still relatively high. Currently, the premium for green steel in the European market is about 100 to 170 euros per ton, which is about 15 to 25% more expensive than the traditional materials. So we have to ask one question, that is, who will bear the cost? For instance, Germany has launched a 6 billion euro carbon contract for different tender to make up for the cost gap between the low carbon materials and traditional materials through the subsidies. Such carbon contracts allow the government to cover the price difference, while the EU carbon border adjustment mechanism turns the carbon liability of traditional materials into real carbon taxes. So simply put, the low-carbon materials are indeed more expensive than traditional ones, but this additional cost can be offset by policy subsidies or actual carbon taxes. So the question facing companies is no longer whether we can find enough green source to buy, but which is more cost-effective in the face of carbon taxes and subsidies.
Well, thank you, Hanxi. Thank you so much for joining us.
Thank you.
And that wraps up this edition of Climate Watch. You can find more episodes on your favorite podcast platforms. Just search for Climate Watch and hit subscribe. Don't forget to leave us a quick review or share it with a friend. You can also email us at radio@cgtn.com with your questions or feedback. And stay updated on the latest climate stories with our Substack newsletter, Climate Choices. I'm Zhao Ying. Thank you so much for listening. See you next time.